Okay, ladies and gentlemen, we're back with question number 6. And so segment GH has endpoints at G, negative 2, comma 9, and H, 10, comma 3. Point J lies on GH between G and H such that GJ to GH equals 1 to 3. Find the coordinates of J. Watch out, there's something slightly different here. Well, you look at it going, GJ to GH, that's 1 to 3. We're actually working on the same thing. But wait a minute, though. Wait a minute. It normally should say GJ to JH is 1 to 3. But it says here GJ to GH is 1 to 3. So let's take a look, though. So we know we have line segment G. Okay, line segment GH. So here's GH. And then we have J somewhere in between. Okay, so J is somewhere in between. Okay, that's a J, actually. I'll try this again. Try to draw a better J here, ladies and gentlemen. So let's just trim that a little bit. Okay, there you go. So we take a look and we see in this case that it should be a ratio of 1 to 3, but here, that'd be like 1n. And from here to here, that's 3n. So GH is going to be 3 times as big as GJ. Therefore, JH has to be 2n. Right? So does it make sense? Because if the whole segment is broken is 3 portions, 3 equal portions, and GJ only is one of those portions, JH must be the remaining 2 portions. So we really have a ratio here of 1 to 2. And so now let's find our differences x's. So here our x1 is -2, our y1 is 9, our x2 is 10, and our y2 is 3. So we do our x2 minus x1 is 10 minus -2, which is 12. And then y2 minus y1, that's going to be our 3 minus 9, which is -6. So, okay. So we're going to take these values. So we're going to take 12 and divide by not 1 plus 3, but really 1 plus 2, which is going to be 12 divided by 3, it is 4. We're going to take our y, well, change the y value, which is -6, and divide by 1 plus 2, which will give us a value of -2. Now to find J. So J is going to be x1, which is -2, plus, now keep in mind, we're looking at only 1 here. So it'll be 1 times 4, because that's the value we changed by. And then our y1 is 9 plus, in this case, 1 times -2. Now you probably ask yourself, do I have to write down the 1 here? I'll write down the 1 because it's easier for us to see where it comes from, so that it's being consistent of what numbers we use. So we have in this case point J to be -2 plus 4, which is going to be 2, and 9, the y values will be 9 plus 1 times -2, which is 7. So point J is going to be 2, 7. Okay? So it does not hurt to draw a diagram to kind of work these questions out, just to get a feel for things, especially when things don't look exactly correct. Sometimes we are autopilot and we make these mistakes that we wouldn't see because, like, well, hey, man, this should be JG to JH. We have to be very careful when we read our problems. Okay, now to our last problem, number 7. And number 7 has a bunch of parts, and so we have here m is point -12 comma -5, and n is 8 comma 10. The third point q is located on mn such that mq to qn is 2 to 3. First we'll find the point q, so this is going to be very standard to what we normally do. And so we're going to start off with the idea that here x1 is equal to -12, y1 equals -5. x2 is equal to 8, and y2 equals 10. Again, we're going from m to n because how do we know? We're starting from m to mq to qn, so we're starting from m to q, then q to m. So we take a look here where our x2 value is going to be x2 minus x1. So we have 8 minus negative 12, which is going to be 20 spaces. So we're going from, when you go from m to n, you're moving 20 spaces to the right. Y2 minus y1 is going to be 10 minus negative 5. And so again, we go from m to n, we're going up 15 spaces. And so now we're going to divide each of those by our sum of the parts 2 plus 3. So we have in this case 20 over 2 plus 3 is equal to, well, 20 over 5 is 4. And we have 15 over 2 plus 3. 15 over 5 is equal to 3. Therefore, our point Q will be our x1, which is negative 12, plus 2 times 4. Okay, that 2 comes from here times 4, all right, comma, our y1 is negative 5 plus 2 times 3. Okay, all right, now again, the 3 here comes from this part here. So I just want to make sure this 3 comes from here and this 4 comes from here. While here the 2 comes from this ratio here. So let's find the coordinate. So Q is going to be negative 12 plus 8 is going to be negative 4. And negative 5 plus 6 is going to be positive 1. So our Q value is 4, comma 1. Okay, so our next question is going to be, in this case, verify that MQ to QN is a ratio 2 to 3 by find the lengths. Okay, so M is negative 12, comma negative 5, and let's put this out here. So M is, so I can remember this, no? M is equal to negative 12, comma negative 5, and N is going to be, we see here, it is 8, comma 10. And I'm going to put the Q here as well because reference-wise, in case I lose track of it and all. So, all right, and our distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1, the whole thing being squared, y squared. Okay, so let's take a look. So we want to show it's a ratio 2 to 3. So we're going to find the measure MQ. The measure MQ is going to be, well, let's take a look. We're going to do negative 12, well, actually negative 4 minus negative 12 squared plus 1 minus negative 5 squared. And so here we see, in this case, we get the square root of, now negative 4 minus negative 12 is the same as negative 4 plus positive 12, which is going to be 8 squared. And 1 minus negative 5 is going to be positive 6, so 6 squared, which gives us a square root of 64 plus 36. That's equal to the square root of 100, or a nice number of 10. Okay, so I'm going to do the length of QN in this case blue, just to have a little differentiation here. So, and so QN will have, in this case, 10 minus 1 squared plus, oh, sorry, not 10 minus 1. That's the y value, silly of me. So that'll come later on. It doesn't matter if we start there or not, but I like to put in order. Okay, so we're going to do, in this case, negative 4, in this case, 8 minus negative 4. 8 minus negative 4, because I'm picking as n is my x2 and y2, and q is my x1, y1, because we're going towards from q to n. So 8 minus negative 4 squared, plus the y2 minus y1 is 10 minus 1 squared. And we're going to get, in this case, the square root of, it's going to be 12 squared, because 8 minus negative 4 is 12, plus 9 minus negative 1 is going to be, I'm sorry, 10 minus negative 1 is 9, so 9 squared. That gives us a square root of, in this case, square root of 144 plus 81, or square root of 225. That's 15. So now when we take a look at our ratio is going to be 10 to 15. Oh, we simplify, it becomes 2 to 3. So we notice that it works out not just from a formula point of view, but it works out in the way of distance formula to verify. Our last part of this question is to write the equation of a line in point slope form that passes through point Q and perpendicular to MN. All right, so we need to find slopes. Okay, so we're going to find the slope, in this case, the slope of MN. So our slope formula, so it's going to be, if you guys remember in this case, our slope formula is y2 minus y1 squared. So it's y2 minus y1 over x2 minus x1. A little too much on the squaring from the previous problem. So let's take a look, all right? And so we see in this case, our value for m and n, so it'll be 10 minus negative 5 over 8 minus 12. 10 minus negative 5 over 8 minus negative 12. Okay, so we would get, in this case, 15 over 20, which is a slope of 3/4. Okay, that's not bad. So slope of 3/4, all right? And so now it kind of makes sense because we get a 3, 4, 5 situation. But now our slope perpendicular, because in this case, we're looking for perpendicular, our slope perpendicular will be the negative reciprocal, which is negative 4 over 3. Okay? And our point Q, if you remember, point Q is going to be negative 4, comma 1. So we put down negative 4, comma 1. And now to find the equation of the line passing through in point slope form. Well, in point slope form, it's not the same as y equals mx plus b, but point slope form is y minus y sub 0 is equal to m times x minus x sub 0. Now you say, which one's which? Well, this is our x sub 0, y sub 0. And that's our m. So we're going to get an equation that's going to read y minus 1 is equal to negative 4 over 3. Just a reminder, the slope perpendicular, parenthesis x minus negative 4. Well, that's awkward though. So we'll do y minus 1 equals negative 4 over 3 x plus 4. So it's actually a really good sheet to review a lot of things, and hopefully this was helpful for you guys to work this out. You can check and make sure that your work came out okay, if you made errors, no, any differences, and of course, if I made an error, you let me know. In any case, have a good time going over this, and this will be on the Regents, okay? They always sneak all these questions on the Regents and all, so where you have to do partitioning and all. Please be very careful, and as always, take care of yourself and be safe. Look forward to you on the next video. In this case, when we go over into our next set of problems we'll have. Okay. If you liked the video, please put a like and subscribe to my channel so that in case any new videos come up, you'll be able to get them before I end up posting them onto our Google Classroom. Okay. All right. Take care. Have a great night.